Hi everybody, Matt here and welcome to the first in a series of videos where we're going to look at writing a networking stack. So this first video is going to provide an overview of the basic principles of a networking stack, as well as introducing our first object that we will code called a packet. So let's dive in. So let's suppose that the user has some data that they want to send onto the network. This is going to get passed into the operating system and will eventually arrive at a subsystem called the networking stack. In our example, the network stack consists of three protocols A, B and C. The data is going to get passed to the first protocol, A, where it will have some data prepended to it. This data is known as a protocol header and contains information specific to that protocol. As the data descends through the stack, each protocol will prepend its header. For example, our data will now move on to the protocol B, where that protocol's header will be prepended. We then move on to protocol C, where the next header is also prepended. Finally, we reach the network card. This is a piece of hardware that is responsible for taking the data out of the computer's memory and transmitting it onto the wire. This is a very basic view of how networking stacks work. However, this isn't the usual way that data is managed in a networking stack, since the constant prepending of data would require many reallocations of the buffer and is a waste of the CPU's cycles. We now introduce a new object that will keep track of all the data in a more efficient manner. So, as before, we have the user data and the networking stack. This new object will be called a packet. This object will then keep a reference to each buffer that forms the complete packet. So it needs a reference to the user data and then it will be passed into protocol A. Protocol A will then generate its header, and rather than prepending to the user's data, a reference to the header buffer is added to the packet object. The packet is then passed to protocol B, where it will generate its header and add that reference to the object also. The object is now passed to protocol C, where again a header is generated and the reference added to the packet object. Finally, the packet is passed to the network card. At this point, we can use a hardware facility called Direct Memory Access, or DMA, to concatenate all these buffers into a single packet and then transmit this on the wire. So that covers how the packet object is going to work when data is being transmitted, but what about the receive case? Well, let's introduce our networking stack and receive a packet at the networking card layer. When we pass this data over to the packet object, we set a variable called curData to point to the beginning of the packet data buffer. This is then passed to protocol C, the first protocol on the receive path. Protocol C will then read its header from curData and increment the pointer by how much data it has read. This has the effect of consuming the data and leaving the pointer at the next header for it to be read by the next layer in the protocol stack. So for example, we pass the data to protocol B, where it will read its header starting at curData, incrementing the pointer as it does so. Then we pass the data to protocol A, where again the curData pointer is incremented as the protocol consumes its header. At this point, we are left with the curData pointer pointing at the user data, which we can now pass back to the user application for processing. So that's a very high level view of how a protocol stack works and how the packet object should behave. In the next video, we will dive into some code and implement the packet object. Thanks for watching.